Clear, lock, tag and try is a safety procedure which is essential whenever cleaning, maintenance or adjustments are to be carried out on industrial equipment. Its aims are to isolate all forms of energy from the area to be worked on, ensure that an accidental release of potentially hazardous energy does not occur, and make certain that entry to a restricted area is tightly controlled. The success of any lock, tag and try operation depends on two things: a thorough education of all workers in the safety rules appropriate to their workplace, and the disciplined exercise of individual responsibility in always following the proper procedures. When work is planned on a piece of equipment, the first step is to determine all sources of energy which must be locked out. To do this, a thorough understanding of the entire energy system associated with the machinery is essential. This may require an examination of the blueprints, which will show all isolation points leading to and from the equipment. A recommended alternative is to have a standard manual for each piece of equipment. This should clearly set out the isolation points, how the machinery is operated, and the safety features and procedures which must be taken into account before work can proceed. The methods used to achieve lockout will vary according to the circumstances. Hooks, chains, clasps and locks are among the most common devices used. A manual valve attached to a piping system is often locked out by putting a chain through the yoke of the wheel and then securing it with a lock. Two valves next to each other can be rendered inoperable by simply attaching one to the other with an appropriate lockout device. In many cases, achieving a lockout requires ingenuity. Here we see an unusual situation in which a section of the floor in a test bay is raised by hydraulic pressure. To prevent the floor falling when work is to be done in the pit, steel pins are used to support the ends, and a bar supports the middle of the raised section. Though the methods may vary, the objective is always the same: to render the machinery and its potential energy inoperable. Each lock should have only one key, and this key is the responsibility of its one owner. This prevents a lock being removed without the worker's consent. The tag, which must accompany each lock, identifies the tradesman, his crew number and his trade. These tags suffer from rough handling and often become dirty and difficult to read. Make sure your tag is clean and legible. Communication with your co-workers is an important part of the process. Let people know your activity, where you'll be working and for how long. Once an assessment of the sequence and methods of lockout has been accomplished, the lockout procedure can begin. The supervisor will go through the various isolation points with the tradespeople who will be involved in the work. The supervisor puts his locks and tags on first. Each tradesperson will then follow and apply his own locks and tags. In some organisations, the lockout procedure will be slightly different and will have the tags applied by the supervisor only. Regardless of this variation, the principles for lockout remain the same. The lockout sequence should begin by isolating the main power source. Remove the fuse from the electrical control box. The box should then be locked and tagged. Extra care must be taken when working with electrical machinery because it can be fed from more than one power source. When locking out a system of pipes downstream from the energy source, be sure that you trace the pipes back upstream to determine exactly what you are shutting out. It could be steam, heat, chemicals, or something flammable. In these cases, personal protective equipment is required. Depending on the nature of the job, face shields, hard hats, goggles, or heat-proof gloves may be necessary. If an emergency develops, breathing apparatus may be required. it is essential that the workers involved have been taught how to use this safety equipment properly. These possibilities must be taken into account during the preliminary assessment. After the lockout has been accomplished, it's time for the try. This means that each energy source must be physically tested to determine that it has been definitely rendered inoperative. The start and stop buttons must be tried out and then secured. Check all handles, wheels, valves and switches to see that they're not functioning. In the case of pneumatic and hydraulic systems, the lines must be bled. To minimise the hazards of breaking into a system which may contain stored energy, be sure to break in away from yourself. By doing this, any dangerous material will move harmlessly away from you if there is a sudden release of energy. The stored energy hidden in a mechanical apparatus must be considered. This roll-up door, for instance, harbours tremendous energy. If the spring should break, the sudden release of its energy could be very hazardous. In cases like this, restraints and blocks are required. Once the try is accomplished, you can be confident that the equipment has been brought to a zero energy level and it is safe to commence work. When the work is completed, the supervisor and tradesman will return the system to its operational status. This is accomplished by following the lockout sequence in reverse order. In systems where a large number of lockouts are involved, it may be helpful to number the tags. In this way, the correct sequence of removal can be easily identified. The tradesmen remove their locks and/or tags first, followed by their supervisor. In other words, the first lock on should always be the last lock off. As we have seen, lock, tag and try procedures can range from the simple to the complex. The solutions you choose will have to take into account the particular circumstances of your work environment. As a guide, there's a helpful checklist of 5 basic questions to ask when considering any lock, tag and try operation. 1. When do we use lock, tag and try? Whenever work is contemplated on idle or defective equipment which can be started or may contain stored energy. 2. Who does the lockout? The area supervisor and the tradespeople who will be involved in the work. 3. Where does lockout and tag occur? At all energy isolating points leading to and from the equipment. The locations will be varied and at times inconvenient, but they must all be scrupulously attended to. 4. What form of energy are you shutting out? Is it heat, pressure, flammable materials? In many of these cases, personal protection will be required. If you are dealing with the stored energy in a mechanical device, restraints or blocks must be put in place. 5. How is a lockout best accomplished? There is only one hard and fast rule, namely that the source of energy is rendered inoperable. Chains, hooks, clasps and locks will most commonly be used to accomplish this, but unusual situations will require unusual solutions. And remember, once the locks and tags have been applied, the try procedures must be implemented. The lock, tag and try system has been set up for your safety. Its effectiveness depends upon each worker's strict adherence to the safety system that has been set up. That's the reason each worker applies his own lock. That way the key to your safety during lockout rests in your own hands.